Good morning, everyone. Today is going to be our first day of online learning. We are going to continue with differential equation and slope field. Let's take a look at question number 1. Consider the differential equation dy dx equal to x plus 1 over y. Part A. On the axis provided, sketch a slope field for the given differential equation at the 12 points indicated, and for x is between -1 and 1 exclusive, sketch the solution curve that passes through the point 0, -1. So we had to use the axis provided. So this is going to be the 12 point that we are going to use. So on this 12 point, we are going to sketch little line segments on it. In order to find out what kind of slope each one have, we had to use dy dx equal to x plus 1 over y. So that means m equal to x plus 1 over y. So this time m is depending on both x and y. And we look at this is a fraction. So we know that fraction have a very special property. So when the numerator equals to 0, and then the m equals 0. When the denominator equals 0, the m is undefined. So we always look at this two part first. So let's figure out, okay, in what situation that we have slope equal to 0, okay, and when the slope is going to be undefined. So we say that m equals 0 when the numerator equal to 0. So that means when x equal to -1, then we get slope equal to 0. So over here, x equal to -1 is entire column, m equal to 0. Which just means we are going to draw a line segment with slope equal to 0 on this column. So we had to refresh our memory. Horizontal line have m equals 0. So we draw horizontal line segment on each dot over here. Now we go back. M is undefined when what happened? So now we know that when y equals 0, m is undefined. So that means we're going to have vertical line segments. So over here, you're supposed to have vertical line segment, but we don't have to graph it because the question never asked. Now we finished the first column. We still had 2 more columns left over. So what should we do? We're not going to make it very complicated. Usually on the AP exam, you will have to draw only have less than like 15 points. So here we had 8 more points left over. And so we're going to do it by column. So now let's take a look at the middle column. So we got so we're going to calculate the slope for each. So we got 0 plus 1 over 2. So we get half. We got 0 plus 1 over 1. We got 1. We got 0 plus 1 over -1. We got -1. 0 plus 1 over -2. We got -half. We're going to calculate all the points before we graph them. So this column, we got 1, 2. And we still have m equal to x plus 1 over y. So we got m. So we got 1 plus 1 over 2. We got 1. 1 plus 1 over 1. We got 2. 1 plus 1 over -1. We got -2. So we calculate out the slope. So after that, we're going back over here to draw the line segment on each. So for the point 0, 2, we get the slope, which is half. So we go back over here. You're going to count 1 up and 2 to the right. So we're going to imagine that we are going to connect these 2 points. The next one is 0, 1. The slope is 1. So you get 1 up, 1 to the right. Imagine you're connecting them. And then the next one will be -1. So you go down 1 and right 1. So imagine we are connecting them. And the next one will be -1/2. So you go 1 down and 2 to the right. You can use some point to help you. So imagine you're connecting this 2. So we finish the middle column. Last column, we have our m equal 1, so which is same as this one. And then you have slope equal 2, 1, 2, 1 to the right. So now imagine you are connecting this 2. The slope equal -2, so you go 1, 2, and 1 to the right. Imagine you are connecting this. And then the last one, slope equal to -1. So just look like that one over here. This one we have slope equal to -1. You can go 1 down, 1 to the right. Now we just finished drawing the slope view. It doesn't have to be perfect. Let's go back to the question. It says that for this interval, sketch the solution curve that passes through the point 0, -1. So now let's go to the point 0, -1. So we had to use this point as our beginning point. We're going to follow the direction. So if I go this way, it tells me I had to go passing this. If I go backward, I have to follow the slope equal to -1. So now this is going to be the solution curve on the interval between -1 and 1. So this is the solution curve. So we finish part A. Let's go to part B. Part B, the question said that why the slope view in part A is drawn at only 12 points. It is defined at every single point in the xy plane for which y not equal 0, because we have the denominator y. Describe all points in the xy plane y not equal 0 for which dy dx equal to -1. Definitely not going to count that infinite number of points on the xy plane, even though we only have 12 points given, but there are decimal in between. Okay, so it's not practical to count the point. That means we are going to use the given information dy dx equal to -1. dy dx equal to -1, and we have dy dx equal to x plus 1 over y. Definitely that means we should do substitution. So we got x plus 1 over y equal to -1. So once we get this, then I'm sure you know what to do. We're going to cross multiply and solve for y. So we're going to get -1y equal to x plus 1. And then we're going to times -1 both sides. So we're going to get y equal to -x minus 1. This is going to be a line. So that means all the points on the line y equal to -x minus 1 have slope of -1. So we found all the points, the infinite number of points. Now we're ready to go to part C. Part proxy is that find the particular solution y equal to f of x to the given differential equation with the initial condition f0 equal to -2. So we had to find a particular solution. So before we find a particular solution, we need to find a general solution. So we had to use our equation dy dx equal to x plus 1 over y. I believe from here, people know what to do already. So we're going to cross multiply and then we're going to integrate. So we're going to get this much. And then next step, integrate. So we're going to continue our integrate process. We usually put the plus c on the right side. We skip this part. So now we still have the denominator 2. So we are going to multiply 2 to each side, just to eliminate the 2. So this cancel. So we get y squared equal to x squared plus 2x plus 2c. You multiply each. And we don't want to have 2c over here, so we're going to let 2c equal k, or you can use b, it's up to you. So we got y squared equal to x squared plus 2x plus k. And we're going to solve for y, because it's a y squared, so we get 2 solution, which is 2 branches in this case. So we got y equal to plus minus square root of x squared plus 2x plus k. We're still not done yet. We still have to find a particular solution. So we had to use the initial condition, which is f of 0 equal to -2. Y equal -2, it tells us to use the branch y equal to negative square root of x squared plus 2x plus k. So now we're going to do substitution and solve for k. So we get -2 equal to -0 squared plus 2 times 0 plus k. And both sides have negative, so I divide by negative both sides. So I get 2 equal to square root of 0 squared plus 2 times 0 plus k. We simplify it, we're going to get square root of k equal 2. And then we're going to square both sides. And then we got k equal 4. So once we find k, so we're going to write down the particular solution. So we just substitute k by 4. So we finish the particular solution. Now we are going to our next part. Our part D. Part D said that let y equal to f of x be a particular solution to the differential equation with the initial condition f of 0 equal -2. So we got a point, 0, -2. And then write an equation for the tangent line to the graph of f of x at 0, -2, and use it to approximate f of 0.1. So we are going to do tangent line approximation for f of 0.1 using 0, -2. So that means we need to do y equal to mx plus b. So we know x and we know y. How about m? If we recall the question, we already know m, which is dy dx equal to x plus 1 over y. So that means we're going to use dy dx equal to x plus 1 over y to find m at 0, negative 2. If you remember, we already did it before, but you can calculate again. So we're going to get 0 plus 1 over negative 2, which is negative half. So now we have all the information. We go back to find b. So we got negative 2, and m equal negative half, and x equal to 0. So we found b equal to negative 2. So the tangent line is y equal to negative 1/2 x minus 2. We're going to use y equal to negative half x minus 2 to approximate f of 0.1. So recall what we did before? All we had to do is substitute the 0.1 into the x value. So we get negative 1/2 times 0.1 minus 2. You can use a calculator, but I'm not going to use a calculator for over here because I can convert half into negative 0.5 times 0.1 minus 2. So that means you're going to get negative 0.05 minus 2. Then we got negative 2.05. So in conclusion, so we say that f of 0.1 is approximately negative 2.05. So we finished question number 1.